Welcome to one and all. Today in this video we will start with the infiltration, which is the another component of the hydrological cycle. Infiltration is nothing but infiltration is the method by which water gets into the surface strata of the earth to meet the soil moisture deficiency. After meeting the soil moisture deficiency, if any excess water remained in the ground, flow vertically deep into the ground and join the groundwater table. So deep vertical movement of the water in the ground is known as percolation. Infiltration capacity. What is meant by infiltration capacity? It is the maximum rate at which soil is capable of absorbing water. Infiltration rate is the actual rate of infiltration at a given time at a particular given place under specific conditions is called infiltration rate. Relation among the infiltration rate, infiltration capacity and the intensity. Infiltration. So if actual infiltration capacity is equal to the infiltration rate is equal to the infiltration capacity, then so if we see when intensity is greater than Fc, what is nothing but infiltration capacity, then actual infiltration is equal to infiltration capacity. And if intensity is less than Fc, actual infiltration is equal to whatever the intensity occurred, intensity of the rainfall, we will consider that one. So these are the problems which has given based upon that one. Factors affecting. What are the factors affecting infiltration? So we will see. First one is porosity of the soil. If the soil is porous, then the infiltration capacity will be more. If the soil is porous, the infiltration will also occur in the greater amount. And the second one is moisture content of the soil. If the moisture content is already present in the soil strata, then it will not easily allow the water to pass through it. So that means moisture content is inversely proportional to the infiltration. Depth of surface retention. If the depth of the retention is more, then the infiltration is also more. More depth, more infiltration will occur. So next one is vegetation. If the vegetation cover is more, then the infiltration will also be more. And the compaction. If the soil is get more compacted due to the population which is roaming on the earth surface, if the because of that weight, earth will get compacted. If the compaction is more, then the pores will get reduced. If the pores will get reduced, then the infiltration will also get reduced. And the next factor is washing of fines. If the washing of fines is more, infiltration will get reduced. And the entrapment of air. If the entrapment of the air is more, and the pores will already filled with air, so then it will not allow the water to pass through it. So infiltration will be less. Temperature. As temperature increases, viscosity decreases and the resistance to flow decreases and infiltration increases. That's why infiltration is directly proportional to the temperature. So how to estimate the infiltration? First one is infiltrometers for field measurement of the infiltration. This is the single ring infiltrometer. And next one, double ring infiltrometer. Right. So third important one is Horton's infiltration capacity curve. Horton has conducted infiltration studies in his laboratory by simulating F is greater than intensity is greater than field capacity on different soils and concluded the following. Infiltration capacity is maximum at the beginning of the storm and it exponentially decreases as the storm duration increases. It attains steady state at some point of time and remain in that state indefinitely. The given diagram is obtained by plotting the observations of the test known as Horton's infiltration capacity curve, and the equation is given as F at infiltration capacity at a particular time will be given as final infiltration capacity plus infiltration capacity at initial minus infiltration capacity into e power minus kt. Right, Fc naught is the infiltration at the time 0, Fc is the steady state infiltration capacity F at a particular time, K is the infiltration rate constant. Using the Horton infiltration rate, total infiltration is given at the time is between any 2 points can be worked out. So infiltration in time dt, a particular time I have taken before it reaches the constant infiltration capacity. Note this point, before it reaches the constant infiltration capacity. Infiltration in time dt is equal to area under the Horton's curve. This is the area under the Horton's infiltration curve at particular time dt. So fct into dt, if we integrate it, then we will get the total infiltration. Infiltration between 2 time intervals will be taken like this. If it is from 0 to time t, integration limits will change from 0 to t. If it starts from ti to ti plus n, then the limits will change according to that one. When the soil has attained its steady state at any time t, then the infiltration capacity after that will be same, Fc. So total infiltration is equal to area under infiltration curve. So if we see this graph, this is the infiltration curve. What is the total infiltration occurred will be represented as the area under this curve will represent the area under this curve will represent the total infiltration occurred. So if we see this one, this is the constant rate which attained. From this point we will take, this is the area of the rectangle, and this will be taken as this value, where K is already known as infiltration constant. So another important and beautiful topic we will come across is by superimposing Horton's curve over rainfall hydrograph along with the infiltration runoff also be estimated. So if the precipitation has been occurred, whereas rainfall hydrograph will represent the intensity into time versus graph. So if I superimpose the two graphs of a hydrograph and the Horton's curve, the graph will be like this. If we see this one, intensity into time will give you the total precipitation which has occurred, and this curve will represent the infiltration, right? Whatever the precipitation which has occurred on the earth, either it has to infiltrate or it will go runoff, right? So if I subtract this total precipitation from this total precipitation, if I have subtract this area, then whatever the leftover portion in above the curve will be my runoff. So in this way we can calculate the runoff. So this is the equation like this. Runoff is equal to total precipitation, that is I into T, and the total summation I have taken from 0 seconds to total T time minus the area under the infiltration curve will give you the runoff. So these are the different types of graphs, and if you see this one, you will be known how to calculate the turnoff from the superimposed hydrograph and the Horton's infiltration curve. So with this I am ending this session. Thank you.